Value of a car v pounds may be modelled as a continuous variable. At time t years, the value of the car is given by v is equal to a e to the power of kt, where a and k are constants. Notice this model is using the exponential function e. When the car is new, it is worth £30,000. When the car is 2 years old, it is worth £20,000. Determine the value of the car when it is 6 years old, giving your answer correct for the nearest £100. First thing I'm going to do is write down the formula. V is equal to A e to the power of kt. Now, the next part of the question did actually give us some information. It did say when the car is new, it is worth £30,000. So when the car is new would mean that the time is equal to 0, the initial value of the car. So when t is equal to 0. So what we know is when t is equal to 0, v is equal to £30,000. So what we can do is substitute these values into the formula like this. So instead of v, I can write 30,000, and instead of t, I can write 0. So the right-hand side would simplify to be just a, because what you have there is e to the power of k times 0. Now, k times 0 is equal to 0, and e to the power of 0 would be equal to 1. Anything to the power of 0 would be equal to 1. Now, if e to the power of 0 is equal to 1, then you have 1 times a left, which would be a. So we worked out that a is 30,000. So what we can now do is substitute that value back into the formula. So instead of writing v is equal to a e power of kt, I can now write down v is equal to 30,000 e to the power of kt. The next part of the question did actually give us more information. It did say when the car is 2 years old, it is worth 20,000. So when t is equal to 2, v was equal to 20,000. If we substitute those values into the formula, we would have 20,000 instead of e, and we would have 2 instead of t. So what I have is 20,000 is equal to 30,000 e to the power of 2k. What I now have is an equation where I can solve to find out the value of k. So if I divide both sides by 30,000, it would leave me with 20,000 over 30,000 is equal to e to the power of 2k. Now 20,000 over 30,000 would simplify to be 2 over 3 by dividing the top and bottom by 10,000. So I know that e to the power of 2k is equal to 2 over 3. And I need to now work out the value of k. Now remember, the inverse function of x is ln x. Therefore, if I want to work out 2k, what I need to do is write down 2k is equal to ln of 2/3. If 2k is equal to ln of 2/3, then k is equal to ln of 2/3 divided by 2. Now this is where your calculator comes in, because you can type that in your calculator and you should get minus 0.2027, and it carries on your calculator. So that's the value of k. So if we go back to the original formula, v is equal to 30,000 e. Now instead of writing k down, we can now put minus 0.20273, and it carries on t. What we do have now is a formula to work out the value of the car at any time. So if I want to work out the value of the car when the car is 3 years old, then I could substitute t to be 3. Or when it's 4 years old, t would be 4, and so on. So going back to the question, it did actually say determine the value of the car when it is 6 years old. So we need to substitute t to be 6. So if I substitute 6 into the formula, we would be left with 30,000 times e to the power of minus 0.202732 times 6, and typing that in your calculator should give you 8,888.9184. So to the nearest penny, that would have been £8,888.92p. However, the question did say that we needed to round to the nearest £100. The nearest £100, it would be £8,900. If you want to investigate this model further and want to visual image and see what the graph would look like, then what we can do is use Geogebra. This is a good tool to help us investigate the different graphs involved with this particular model. If we have a look at this area here, then we can type in our equation. If we press this button here, what we can then do is decide on the range of values that we want. I've gone for years 0 to 9, and as you can see, year 6 does actually match up with our answer to the exam question. As you can see, though, the graph hasn't appeared. This is because the scale on the y-axis isn't suitable for the values in the table. Now, if we click on this icon, then click on settings, you can now change the scale to be more suitable. The least value for the x-axis should be 0, as the x-axis represents the time, and the initial value of the car would have been when the time was equal to 0. I've only put -2 as the minimum, so the scale will actually come up on the screen properly for you to see. Otherwise, you wouldn't see the y-axis. And I've just put the maximum value of 40,000. So you can see after doing that, the graph is automatically generated on the screen. So you can see you've got the exponential model, and we can see the different values over time. Geogebra is a useful tool to investigate shapes and patterns of graphs. For example, we can see what happens if we change the initial value of R, for example. Remember about this icon. If we click on this button, you can choose table of values. You can also change parts of the equation. So for example, here I've changed the initial value of the car from 30,000 to 20,000. And we can see what would happen. It will automatically generate the graph immediately for us. And if we click on this button, we can also see the table of values for comparison.